Good evening, my dear friends. I welcome all of you to the Edureka's data science web series. And let me know, am I audible to you guys, first of all? Can someone write it to me? Am I audible? Audible? Yes, great. So we can start the today's session. And today we are going to study about the KNN algorithm using Python. So till now we have seen few algorithms of classification, like we studied about the uh, logistic regression, then we studied about the random decision tree, and then yesterday we saw the random forest, and today we are going to discuss about the k nearest neighbor algorithm, and again it is also a classification technique. Okay, so let's start it. So KNN algorithm or K nearest neighbor algorithm, you are going to see it is one of the very easiest algorithm, and still it can give very good results in many cases. So let's see what is KNN algorithm, right? So we will see what is KNN algorithm in today's class. Then we will see some of the use cases of KNN algorithm, how it is being used in industries, and then we will see how things are predicted using KNN algorithm. And like here in KNN, we have one term K. We will see how we can choose the K. And at the end, we will do the implementation of KNN algorithm using the Python scikit-learn library only. Okay, so what is KNN algorithm? Even though writing the code for it from the scratch will not be a very big task, it can be done easily as well. So let's discuss this thing. So we are going to see what is K in KNN algorithm first of all. So K talks about the number of neighbors. So what is the number of neighbors? As we will go through the algorithm, we will understand what is the this K value represent, right? So in a short, if I have to tell, so K nearest neighbor algorithm works in such a way that you look. So let's say you have a data set initially, and then you want to predict for some data point, right? What would be the class for that particular data point? And then you are talking about the K, where K we are talking about the nearest neighbor. So for that particular data point, we will see which are the nearest neighbor to that particular data point. And if we are talking about K is equal to 3, let's say, then we will see what are the 3 nearest neighbor to that particular data point. And then you will see among those 3 data points which class is coming maximum number of time, right? So which particular class is being voted mostly, and that is how we will do our prediction. So we will see it in detail. So it's just a very small introduction, and K values could be anything 1, 3, 5, 9, right? And we have to find the right K values itself a challenge, which we again need to do few things. So K is number of nearest neighbor here, which we are going to discuss. So let's talk about the Amazon case study. So if we talk about the Amazon case study, here you are getting the recommendations, right? So how is it giving the recommendation? You can think it like K nearest neighbor algorithm. How so? Let's see, you are basically you are taking one particular product, right? And you are saying you are searching for a particular product, and you click on to this particular product, let's say, and you visited that page. Then in the uh, then in the uh, in the recommendation, it starts showing which are the nearest neighbor to this product which you are buying, right? So it shows in many different ways. It says customer who bought this also bought these items, or it might be on the basis of the content of the item, like which have the nearly same kind of content which you have here, right? So let's see the next case study here. And you can use it for quality control workshop as well. So like in industry, it can be used as a quality control workshop, where basically using the machine learning, you first teach it which are the defective part and which are not the defective part, right? And then after that, it will automatically classify by looking into the new product whenever is being generated. Then it looks which are the nearest data point are to that. And if most of the nearest data point for a particular image, let's say if you're taking the image of the object or the material, is defective, then you will say it is defective. Otherwise, you will say it is fine, right, or good ways. Okay, now let's talk about how does our KNN algorithm work exactly. So first of all, we get the data set, right? And let's say we have the two classes data set. Blue color represent one particular class, and this orange color represent another particular class. So what is your aim here? Your aim is to do the prediction, right? So on what basis you will do prediction, we will see this thing. So here, this is the given data set, like we say the training data set, right? So this is our training data set. Here, these are the, let's say, one particular class, we call it as a blue class, and here we call this point as a orange class, right? So we get all these data points. Then after, let's, like here, orange point they're calling as a class, blue point they're calling as a class A, and the orange points they are calling as a class B. Let's say now you want to do the prediction for this particular star, that to which particular class this data point will belong, whether it belong to class A or class B. So, and after that, what we will see what k value we have chosen. Let's say if you have chosen the value of k is equal to 3, it means k is equal to 3 we are choosing, means 3 nearest neighbor to this particular data point we will calculate, we will find out, right? So when you find which are the 3 nearest data point, so one would be this, another 2 would be this, right? Because compared to these 3 data point, if you look into any other data point like these, you will see their distance are more compared to these 3 data points. So what is the aim here in the k nearest neighbor algorithm is to find out the nearest neighbor out of the data set from the training set, right? So these were our training set, and now for this particular point you want to do prediction. So you find out the k number of nearest neighbor to that particular point, and in this case these two are coming from orange class, and one this data point is coming from the blue class, right? So now it's pretty easy for you. And if I ask you what value you will predict for it, so can you answer in this case what value you will predict for this particular star, whether you will predict orange class or you will predict blue class? What do you guys say? Anyone, any answer? So one person, webinar registrant, is saying I will choose orange. Great. Any other answer do we have? Okay, great. So as simple it is, we will do the voting, right? So these are the neighbor to that. So we say it is more likely to its neighbor, right? And here we will see that these compared to like out of these three, two of their neighbors, two of its neighbor are orange. So according to the voting, orange color has gone, right? So we will choose here orange class. So you can see how simple algorithm it is, and yet it is very much powerful. Here we have, right? So this is when we choose the k is equal to 3. But what if I choose the k value is equal to 6, right? That is number of neighbor which I am choosing is 6. Then you will find out the 6 nearest neighbor to the 6 nearest neighbor to your data point, right? And now when you find these 6 neighbors, these are the data points which you will get, right? And now which you will choose here in this case, what you guys will choose here? We are getting blue answer, blue, blue, blue. Great. So definitely blue is near in this case. So we will choose blue class. So one person, that is Shoram, is saying orange from the YouTube. Why you are saying it orange? Okay, maybe you are again looking only the which are the nearest data point actually, right? But if you look, if when we say 6, so it means we are going to consider the 6 data point, right? So we are talking here very simple algorithm. So we are saying, okay, 6 data point, and we will do the voting here, and according to the voting, the blue color is winning here in this case because there are 4 blue point into the 6 nearest neighbor and 2 orange point. So depending on what value we take the k, our solution may change as well, right? And here let's go. So, okay, before coming to this case, Let's go back to this, right? So if there is a one more thing, like some of you might want to say one thing, that what why blue color seems to be very far away, right? So it means it may happen sometime. Let's say I have a data point which is let's say somewhere here, not even here. Let me do one thing. Somewhere, where shall we make it? Let's say, yeah, here it is, right? Far away from this even, and here it is, right? And very closest, there are three data points are there, or let's say four data points are there. These are the oranges, suppose, right? So if I consider till four, so very easily it would be said as a orange, right, properly. But if I take, let's say, 9 point, and let's say at the far away from here, it is having these crosses, which is are, let's say, are my blue point is only, right? So because of this, when you will find out 9 nearest neighbor, then it will be, and you might predict this particular point as a blue class or this cross class rather than this circle class or orange class, right? What is the reason? Because we are considering only 9 nearest neighbor. But if you see here, and then if I ask you what do you think it should be class from your intuition, right? Do not consider k and 9 neighbor or 5 neighbor, 2 neighbor. Then definitely you will say it comes under the cluster of this circular form or orange color. So it is better that if we allocate this particular class only, which is orange, rather than using 9 nearest neighbor, which is far away. So what do we do in some cases? Now there are, even though we are not going into this detail, but to make it little interesting for you guys, I am saying that here, not only the you have to look 9 neighbors, but the weight also you provide to the each vote depending on the distances, so that the vote which is being given by the nearest neighbor would have more value compared to the vote which are the far from it. So because of that, what would happen in this case? If you add the weights according to the distance, so these are the closest ones, so their votes will have more weightage compared to their votes, right? And because of this, then again it would be made as a this circular point only, right? Or it would be predicted as a circular class only, right? So that is a little bit change in the normal k nearest neighbor. Normal k nearest neighbor is this only, right, which we discussed. But on the basis of weight also, things are being implemented in doing this thing, right? So like Mehul Bua is saying, it may choose using Euclidean distance, right? So you using Euclidean distance or Manhattan distance, there are lots of different distance metrics are there, and it can choose any one of them, right? You can choose any one of them. So let's see how to choose the value of k, right? So on this particular these data points, right? So if I forget about this orange point, actually first let's forget for a moment about this star point, and let's say this particular thing is this particular data points are given, right? The orange and then these blue points are given. So if you have to decide that what should be the boundary, right? So you can create the boundaries also. So how you can create the boundaries here in this case? So you see, so like here, if my data point is there, so to how many, if we are talking about, let's say three, k value is 3 only, right? So what would be boundary in this case? So if here it is, it would belong to orange. If it go little bit up, still it belong to orange. If it go here, then still it belongs to orange, but here it start belonging to blue. So you might decide the reason, right? So in the reason in which, if the data point is here, to which particular class it will belong. Let's say it will belong to this class, so the reason would be like this something, right? So like this way you can decide the reason on the basis of k value as well, right? So this way it might be going done further straight way. So this way you can say whatever data point will come onto this side, it will belong to orange class. Whatever will go this side will belong to blue class only. But how this reason is being calculated? Again on the basis of neighbor only, right? It is simply mean that if my data point is here, right, then if you choose which are the closest to according to the, if you find out three nearest neighbor to it, one would be this, these two would be this, so it will belong to orange class, right? But if it goes here, let's say, then what would happen for it data point? these two would be from here and this one would be from here. So it will start belonging to the blue class, right? So using this, we can draw the boundary exactly that from which particular point, if further away we go, how the classes would be changed, right? So even though this is k nearest neighbor algorithm only, but on the basis of data set which is given to us, we can find out the boundaries as well, right? And so here, then directly rather than looking distances calculating, we can use the boundary itself, which we definitely calculated on the basis of k value only, right? So if we have the k is equal to 6, then boundary would be different, right? So let's say if we are considering k is equal to 6, then rather than from here boundary might come something like this, right? And here you can see these 2 points would be misclassified, because if here the data point is, then not exactly in this case here, one is this, one is this, one is this, then this is also coming, and let's say this will come and this will come, right? So nearly equal we would have, right? So boundary we can say somewhere here it would be coming, right? If we choose the this value, right? So even if this star comes here, right, it would be still allocated this blue class only, right? But here if it comes, then it will start getting the orange class. So we are deciding this boundary completely on the basis of number of neighbor only, right? So what do we do then? So how do we decide the k value? Definitely by looking into the boundary, right? So if we take k value is equal to 1, let's say this is our data set completely, right? So these data points, orange class, blue class, right? And using these orange region area color, this orange color region is showing the where it will be predicting the orange class, and this blue is showing the where it will be predicting the blue class, right? So if you take k value is equal to 1, then what you will get here, that all these data point would be predicted this way, and these blue point would be predicted, and this one data point would be predicted separately here as such, right? And if you take k value is equal to 3, so you can see how the boundary is going here, right? But if you take k is equal to 3, you can see there is a little bit change into the boundary here, and then your this boundary would be this way, so you will get prediction according to this boundary now. But if you increase it, k is equal to 5, then this is how the things will happen, right? Your boundary would be coming something like this. If you choose k is equal to 9, then your boundary would be coming into this. So tell me, you guys, tell me yourself that what do you think, which value of k you will choose in this case? By looking into this data set, what value you will choose for the k here? Can anyone would like to write here? Right, so in this case, what would be the optimal value of k? So one answer we got is the k is equal to 3, right? So I will also go, yeah, right. Vivek Jain is also saying k is equal to 3, right? So if we see this k is equal to 5, then here we can see there are two data points which are getting misclassified, right? And some of the data points which are coming very much at the boundary, right? And in the case of k is equal to 9, more data points are getting misclassified here, right? One is this, and this. So number of data points which are getting misclassified is increasing with the value of k is equal to 9. But if we see the k is equal to 1 and k is equal to 3, there is like, even though k is equal to 1 looks very much perfect example here, right? There is seems to be, for the training set, it seems to be the, it seems to be very good method, right? It seems to be very optimal result, because on the training set, it will give you 100% result. And in the case of k is equal to 3, it will not give you 100% result, right? But still we will choose k is equal to 3. Why so? Because k is equal to 1 in this case, even though we have this way, and each of the training data point would be classified correctly. But the problem with this would be overfitting, because it is making the boundary on the basis of each and individual data point, right? So sometimes there might be noise as well in our data point. So if we have some noises some places, and if we are using just k is equal to 1, so those noise might impact a lot our data set, right? So in this case, k is equal to 1 may be really, overfitting issue might arise in the case of k is equal to 1. But in the case of k is equal to 3, yeah, one data point is being misclassified, but this is a very well generalized way, right? So because we are getting a one proper boundary here using which we are dividing the regions completely, right? So that is the way we can choose here. And let's look into the Euclidean distance, right? So Mehul says I choose 1. Jagnesh says k is equal to 5, right? But as I discussed just now, did it clear you, both of you guys, Mehul and Jagnesh, why we will not choose 1 and 5? Okay, now let's talk about how the distance is being calculated between the data points. So the distance between the data point is being calculated on the basis of different distance metrics, and one of the distance metrics which can be used to calculate the distance is the Euclidean distance, right? So if you see here, this particular, let's say this is a one data point, this is one data point, and between these two data point you want to calculate the distance. So how you will do? You will do the Euclidean distance, right? So how does Euclidean distance you will do? So this point is 1 1, this particular point is 5 4, and Euclidean distance formula is pretty straightforward using Pythagoras theorem itself, that you will get x1 minus x2 whole square plus y2 minus y1 whole square and under root of that. So this way you will be calculating the distances here, and here you are getting the 5 as distance. Similarly, you can choose the Manhattan distance. Manhattan distance is little different. So webinar registrant is saying, how did we get P254? Okay. So what the way you are taking the the way you are taking this quadrant is other way, but this is different way we have taken the quadrant. Here we are starting from the this. So let's say normally you take this quadrant, right? So you take 0 1 2 3 go this way, like 0 1 2 3 go this way, and here 0 1 2 go this way, right? So this is what normally the this is the this is what you normally saw as a coordinate system, right? But you think, how do we decide the coordinate system? That's our choice completely. Let's say the coordinate system which you are defining is, here is your center, and that is how it is increasing from 0 1 2 3 4 5, and here it is going 0 1 2 3 4 5, right? So this way we say that this would be 5 4, right? So it is 5 on the x-axis and 4 on the y-axis, and that is why you are getting this as a 5 4, and this is as a 1 1. Got it? Great. So one person from the YouTube, Sanidhya, is saying, if the Euclidean distance is in negative, Sanidhya Tyagi, Euclidean distance will never be in negative, as Mehul also said, right? Because we are using here the square, right? So if it comes as a negative still, then you take the square and it will be positive only, right? So Mehul also gave the answer on the YouTube. Thanks, Mehul. Let's go to the next distance measure, which is our Manhattan distance measure. So Manhattan distance measure, how does it work? So it works pretty simple way, that rather than having under root and square here, you just take the modulus, right? So you take the positive value. So like you write y2 minus y1 modulus plus x2 minus x1 modulus, or x2 minus x1 modulus plus y2 minus y1. So 5 minus 1, take the modulus, plus 4 minus 1, take the modulus, so that you always get the positive value of distances, right? So 5 minus 1 is 4, 4 minus 1 is 3, 4 plus 3, you get the 7 here. Okay, so this is our Manhattan distance. Okay, so here they are showing the distances. If this is like, this is nothing like actually like Manhattan or Euclidean distance, we can say here, right? So if we normally, let's say this is the way we normally go, right? So here, if this is the way we go, one way is to find the distance this way, and another way is that you keep the straight line, you join them with the straight line as such, right? But you count the number of the cells here. So Mehul says, how can I know when I use Manhattan and Euclidean distance? There is no as such any rule whether in which what I should choose here in this case, right? That is depending on the mostly on the problem statement. If you are working specifically with the some kind of problem where let's say distances directly uses, right? The real physical word distances are being used. Then definitely you go for the Euclidean distances, right? So depending on how the value is given to you, one thing is this, right? Means what measure can be used, but it is more of the you try with them, right? So as such, in many cases, it does not make much big impact on the result as well, right? So as such, there is no issue. Mostly we'll find very small changes happen when you change these distance measures, but still it is good if you try with both of them. Okay, great. Now there is a one very good thing, or you can say bad thing at the same time, that we call KNN algorithm as a lazy learner, right? So like relax and take it easy. That is what is the fund of K nearest neighbor algorithm. So we have the two kinds of algorithm. One we call as a lazy learner algorithms, and other algorithm we call as a eager learner algorithm, right? So we have two kinds of algorithm. One is eager learner and another is lazy learner algorithm. So our this k nearest neighbor comes into the lazy learner, right? So why does it called as a lazy learner or eager learner? What does it mean actually here, and what are the pros and cons also we will see here. So eager learner means whenever you are doing the training, right? So whenever you are training, then during that time itself, eager learner is doing its lots of computation, calculation, and learning whole data patterns during the training time itself, right? But lazy learner do not do anything during the training time. You give them when you are providing them training, they are not looking what you are providing them. They just keep the notes whatever you are providing with themselves, or we can say whatever data set you have provided, they keep it with themselves, right? While eager learner is doing all the kind of calculation during the learning phase itself. When it comes to, so eager learner do what it basically do, it's all calculation during the training, and it find out some kind of function. Let's say y is equal to fx, it find out, right, where x is input and y is output, so that when you provide the x further, then it just put this function and you it gives the y value to you, right? So in the case of regression technique, logistic regression or linear regression, it was finding some kind of equation when you were training, and in the case of decision tree, it was creating the decision tree, or in the case of random forest, it was creating the random forest when you were training it, right? So during that time itself, during the time of training, it do all the calculations. So it takes a lot of time during the training, right? So it takes too much time during training, right? But when it comes to prediction, because it has already calculated this particular function, which is y is equal to fx. So because of this, what happened whenever you ask it, it is very fast in prediction, right? So it is fast in prediction. But let's talk about now lazy learner. So lazy learner k nearest neighbor algorithm is one of the lazy learner algorithm. And how does it work actually? So it works in the way when you are doing the training, it is just storing the data set, right? So when you say train it, then it store the data set, right? So what it is doing is storing the data set with itself, nothing doing any calculation. So no time, right? So no time taken during training, because during training it is sleeping, right? Doesn't do anything, just keep the notes whatever notes teacher has provided, but didn't learn anything. But during the prediction, then it is doing all the calculation, right? So all calculations being done are being done, right? So it takes a lot of time, right? So it takes time during prediction. So in the case of k nearest neighbor, what is happening? When you train it, it just give the data set. But when you give it data point to make the prediction, right? So like in this case, when you give this particular data point, that is star for doing the prediction. Then at that time it read the data set and find out the distance from this data point to the all data point distances. So it has to read whole data set, right? For doing one prediction, it has to read full data set, right, to find out which are the closest data point, and after that it do the prediction. So it takes time when doing the prediction, right? Similarly, when you take some other data point, then again it has to read whole data set to find out which are the nearest neighbor to that particular data point, right? So as many time you do the prediction, that much time it will take. Every time it will take, it will do its calculation for finding out the distances. But while with the eager learner, it is not the case. During the training itself, it take time. It do all the calculation. Generate, in the case of decision tree, it generates a decision tree during the training phase or whatever, right? In all the cases, this is the way things are being taken care. Okay, and so Sanidhi is saying, what's better for faster calculation, eager or lazy? So depending what you want to say faster. If you are looking for faster predictions, then definitely you should go for eager learner, right? But if you are looking for faster, faster training time, then you should go for the lazy learner, right? So both have their own pros and cons. One is faster during training, one is not doing anything during training at all, right? So that's the thing here that we have. Okay, so I hope so this is clear to all of you guys. Now let's talk about, right? So Mehul is saying it is dependent on our problem statements. Yeah, choosing algorithm depending on the problem statement, completely one thing, and definitely definitely also how much time do you have? Do you want to uh, do you want is it's okay for you if it takes little bit time for each prediction, but you want to deploy your model, let's say now itself, right? Then you call it as a then you do it during the you use the k nearest neighbor. But if you are saying, okay, I have 10 days, 15 days, okay, let's train the model properly, and after that I want prediction should be happen so quickly or faster, then definitely you can use the eager learner algorithm you need to choose. Okay, and if anyone has question, you guys just can write. And now we are going to do the k nearest neighbor classification, and again we will apply it onto the same data set which we saw in yesterday's class as well as day before yesterday class, right? So that it become easier for you guys to understand this particular data set, right? So quickly we will go through this data set, and today we will implement it using the k nearest neighbor algorithm. Okay, so this was the daily weather data set which we had yesterday we saw, and we looked into its top 5 rows. And when we see here top 5 rows, then we are finding here, we were having here number, and here we have air pressure 9 a.m. Then we have air temperature 9 a.m., average wind direction 9 a.m., and other columns values are given. And similarly here we have the relative humidity 3 p.m., right? And this is what we want to do the prediction. So whenever everything is given at the 9 a.m., let's say tomorrow at 9 a.m., I get all these reading, what is rain duration, rain accumulation, maximum wind speed, relative humidity at 9 a.m., and wind direction, and all those things. Then I want to do the prediction that during 3 p.m. in the evening tomorrow, what will be my relative humidity, right? So this is the data set we will take, and here this is we look if into little bit detail of the data set by writing df.info. Then we see here we have total number of rows is 1095, and after that this is number is complete 1095, it means no null values. But air pressure 9 a.m. we have 1092, it means three null values are there. For air temperature 9 a.m. we have 1090, it means five null values are there, right? So we can see in many different columns null values are there. In these two columns no null value, in this column no null value, but in other columns we have the null values. So we need to handle these null values first. before doing anything. So if we want to see which null values are there, then we write df dot is null dot any. So around x is equal to 1, so that it gives us where the null value is 1, and then we are reading those rows. So these are the rows where we have some null values, like into this particular row. Here we have null value in this row. Here we have null values, right? So a lot of null values here we have. Now we are removing two things. One is this particular column, which is number, because this number column is not showing anything, but these are just the kind of ID, right? And what is the number column is never going to impact my humidity, right? So we are just removing this column. And for removing this column, we call the function drop, df.drop. We write the name of the column which we want to remove, which is number here. Then we write the, because it is a column which we want to write, so we writing here x is equal to 1. If we write x is equal to 0, then it will see to do the, it will try to remove the row, and then we look the in place, we say in place is equal to true, because permanently we want to delete this particular column. Then we drop the null values, all the rows which are having the null values, right? And after that, if we see here, then we can see after dropping the null rows, we are getting 1064 rows. And now all these column has 1064 rows only. It means what? Now my data set has no null value, right? So it has zero null value now, right? So we can execute it as well. Then if we can see again what is my top 5 rows here, right? And here now what we are going to do, because we are going to use the classification technique, and this is the column which we want to predict. So rather than keeping it like a regression thing, we convert it into a classification problem by saying whether the humidity would be high or low, right? So let's say I want to convert it. If so, we are creating here a new column whose name is humidity well. So we first of all created a new copy of our data set, which we stored into the df2. And now within this df2, we are creating a new column, and the column name is humidity well. And this is equivalent, we are writing to df2 relative humidity 3 pm is greater than 25. So it will return the true wherever the value is greater than 25, and false wherever value is less than 25. And if we multiply it by 1, then true multiplied by 1 will become 1, and false multiplied by 1 will become 0, right? So this way we make it into a classification problem. Here now we have the classes, whether 1 class or 0 class, which we want to predict, right? So this is we have done here, and we see here now, right? So once we created this column, we do not need this particular column, right? So we can drop this column as well. So we drop this column relative humidity 3 pm, and then we divide our data set into the input variable, output variable, or we can say dependent variable and independent variable. So first our dependent variable is y, and this we are taking whatever value we have in the humidity well column, and the rest column would be my x. So by removing humidity well column from dv to df2, whatever is left will become my x-axis only, right? So did I executed it? Yes, we executed. So it will give us error now in this particular row, because we executed already this particular command. Re-executing this command, because it will not find this column because we have already removed, so it is giving error, right? So but we doesn't need to worry here. We take the y value, we take the x value, and we look into the x, that is our independent variable or input variable. We can say output variable is not there, and we look into the output variable top 5 rows values. So for these 5 rows, corresponding to these 5 rows, we have these 5 values here, right? So we get xy here. Let's execute it as well here. Now we are going to divide our data set into training and testing set itself, right? So as I have mentioned in earlier class as well, that too, so it is equivalent as during the class I have a book where I have 100 questions, with their solutions. So first of all, I will train you on the 70 question by showing their solution as well, and then the rest 30 question whose solution I have not shown you, I will give you as a test paper, and then I will ask you what answer for these question, and whatever answer you give that for them, then I will match those answers with the real answer. So same thing we are going to do here. So we will divide our data set into training and testing set. So we are saying test size would be 33%, and we are keeping in the train X. Train X will be having the training questions. Test X will have the testing question. Train Y will have the training question solutions, while test Y will having the solution for the test questions, right? And if we look their shape, so let's execute them. And when you will see their shape, then you will find that there are 712 questions we have created. For them I will be showing the solution, right? And testing question we have created 352. For their answers I will keep as a secret, and at the end I will use for matching, right? So now what we are going to do here, we are going to implement the k nearest neighbor algorithm. So how do we do this? So from sklearn dot neighbors, within the neighbor we will import k nearest neighbor algorithm, right? That is k neighbor classifier, right? So we import it, and after doing this k neighbor classifier, then we will create its object, right? So KNN is equal to k neighbor classifier, and here we can see what are the different metrics we can pass to it, right? So we can give the number of neighbors. So by default, how many number of neighbors are there? We have the 5 neighbors by default, right? So weight is equal to uniform, like I told you already about the weights, right? Like on the basis of distance we can decide the how much weight should be given, right? So that is the weight, and by default its value is uniform. And you can give, like if you want to do the weight on the basis of some distances, you can use the distance measure so that it would be inversely proportional. So closer the data point, more it will have weight, farther the data point, less it will have the weight. Similarly, if you want to define your on function using which you want to give the weight, you can define your on function as well, right? So there are different algorithms are there within the k tree, k nearest neighbor itself. We will not discuss about them currently, right? So leaf size also we will leave as such. And then the distance metric, like you were saying distance metric, like some of you are interested in knowing the distance metric. Can we choose the distance metric? Yes, you can choose it. By default it is a Minkowski distance, right? And the distance metric which is used for the tree, and there are different metrics are there, like you can use the Euclidean distance as well, you can use the Minkowski distance as well. And you can see the documentation exactly to know how you can use this, right? So if you go to the sklearn documentation, there you can see what are the difference metrics you have available, right? So within these metric you can define those value, right? So these are the some of the parameter you can play. So like here we want to have this n neighbors, right? So let's state it around 3. Let's start it with the 3, right? We will see exactly what result it generates, right? So if we have the 3, and then we do the KNN dot fit model only, and then we pass here our train X and train Y, right? So it fit over it, and after fitting it, then we do the prediction. So KNN dot predict, and then we pass the test X, and we can take its output into, let's say, KNN output is equal to KNN dot predict is this. And then after that we can look for the accuracy score. So for that we need to import from sklearn dot metrics, we need to import the accuracy score. and then we can call this function accuracy score. We give the correct result, which is test y. We give KNN OP, right? So if we look here, we can see it is giving us 88% accuracy, right? 88.3% accuracy, and this is what accuracy we got for decision tree and random forest around also, right? And we can try with different k value as well, so that you can look exactly how the value is being changed. So if we see here, as I increase the number of neighbor, you can see accuracy has decreased here, right? So compared to if I make it 7 even, so what do you guys expect? It is increasing here, right? So it is not like always that if you keep increasing, then it will be reduced or it will increase, right? As such, there is no particular way. It sometimes happens just like that. But better the result you can get with the lesser number of number of neighbors, then better it is. But definitely it never should be the one, right? Even 3 is not the thought to be practically good value, even though we are getting here 88% accuracy, right? So bigger the number we have with which we get good accuracy, better it is. So because there would be less chances for our for the overfitting. The chances would be that it would be this particular model would be more less chances of having overfitting compare where you have the less number of neighbors. Okay, so that is how you can play around with the k nearest neighbor, right? So I hope so this is clear to all of you guys, and if anyone of you have any question, let me know. And again here you need to do again, as I'm saying here, like you need to choose the different parameter. You need to see how the result it is giving for the different parameter. Okay, so let me know any questions, any other question do you guys have? If no, I will tell you one more thing. So can you guys we can use the k nearest neighbor for regression as well, for regression technique as well. Just in place of k neighbor classifier, you can write k neighbor regression. But can anybody guess then what it will do in this case, right? Let's say if this is a data point for which you want to do the regression, how it will do, right? So there are many different metrics out there. If you want to get the list of that, then here we can write simply like sk learn k near k neighbor classifier, so that you can just visit to this particular documentation, and here you can see exactly in the detailed way. Here they give here, once again, are they given the metrics min cos k, the distance? So one is, this is a callable as well, means you can define your own function also to find out the distance, right? So you need to use the distance metric class actually to know all the distance measures which we have, right? So if we write this, if we write sklearn, then you will get the distance metric, which are available distance metrics you have, right? So there is a Euclidean distance is there, Manhattan distance is there, Chebyshev distance is there, Minkowski distance is there, W Minkowski is there, Euclidean is there, Mahalanobis is there, and what is their formulas are also given here, right? So properly you can see exactly how these distances are being calculated, and you can use them as well. Okay, so these are the different distance metric which you have. Okay, so let me see if any other question. Yeah, we were discussing about actually, right? So instead, so like Vishal was saying, instead of classification it will give a real value, right? So how we can have the real values? So how we can have the real values? Basically, let's say if this value is 12. For this, let's say output value was 12, because till now we were saying it is a orange class. This value was having 13 and this was having, let's say, 5. What you will see, so there is no blue and red class in this case. Each of these values have some real values, right? So now what you will do, how you can do this thing? Any answer, any guess? Anybody wants to make any guess? Anybody wants to think something here? I'm waiting. Like, YouTube video is like around 2 minutes late, 1 or 2 minutes late. So I'm waiting as well for YouTube people also to comment, if somebody can comment from there. Linear. What do you mean by linear here? Ahad Khan is saying linear. What do you mean by linear here, Ahad? New value should be 7. RMS value, root mean square value. Okay. So different measures can be used. One of the measure which can be used is the average of all these three values. Another measure which can be used is basically their average with their distances also. So how far away from these are they will get the weightage, and accordingly their values would be averaged, right? So different such kind of measures you guys can use here, and it can work as a regression technique as well. Okay, so I hope so this is clear to all of you guys, right? And now let me see if any other question is there. So Vishal is saying we will find distance from each point and take average and median. Yeah, you can do it on the basis of median as well. It's perfect. Mean, median, mode can also be used. So different statistic measure can be used as well. Okay, great. Okay, great. And I think you guys have been already told. I have shown already meetup.com Edureka. So like there are around 100 plus webinars. I think 150 plus. Earlier it was 100. Now it has become 150 plus webinars. You guys can access freely. You guys can learn, right? And for that, you guys can just visit this particular link and you can click on join this group, and then you can work around this particular you would be able to access lots of webinar directly, right? You doesn't need to be on the YouTube. Then I think you can join these webinar directly here, which would be where I can get your question more directly, and you will have more you will have more preference for your questions to be answered, right? So I hope so this is clear to all of you guys, and so we will finish here today's session. And okay, let me tell you one of the, okay, before finishing it, let me tell you one of the place where k nearest neighbor algorithm is being used, right? So one of the place where it is being used is face recognition system as well. I don't know how many of you are aware about the face embeddings. So like face embeddings basically take a face image and then it converts it into a some kind of columns value for you or some features. So like if image is of size let's say 700 cross 700, then 700 cross 700 is like 49, I think how much it would be, 49,000 or more, 4,90,000 something, whatever it is. So these would be many values. You have many pixel value. So this what face embedding method do, it converts it into a 128 values, or you say 128 features, or you have 128 columns. So for each face you have 128 columns value, right? So after that, the people applies the k nearest neighbor classifier also there for doing the prediction of the faces, for doing the face recognition further, right? So it gives you just the this embedding method, just reduce the number of features, and after that you can choose the k nearest neighbor algorithm for deciding whose face is it. So it is equivalent to that for each person you keep, let's say, 20 faces in your database, right? So if you have, let's say, 10 people, then you are keeping 20 faces for each people, so you have total 200 images in your database or data set. And now a new image come for whom you want to predict which person is he, right? So basically you let's say if you are working with the 5k 5 value of k in the k nearest neighbor, then you will look there in what is the value of 5, right? And after that, so which are the 5 closest faces you will find out, and then you will see out of those 5 faces to which person most of the faces are belonging, and then you will predict, okay, this particular face belong to this person because to most of the images this face has belonged to this particular person, right? So that is how you can implement your face recognition algorithm using the k nearest neighbor algorithm as well. Okay, guys, so let's finish the session. Thank you very much, guys, for listening with so much patience. Suresh, always appreciate. Thank you, Suresh. Suresh is saying, awesome session. Thank you very much. Yeah, thank you for appreciating. Suresh and Roy, two people always appreciate. Thank you, Roy, for appreciating. Thank you very much, guys. And let's finish the session. Okay, guys, thank you very much. Good night, sweet dreams.